अच्छा जी। अच्छा, अगर ये हमने लास्ट क्वेश्चन किया था तो वी गो टू नेक्स्ट क्वेश्चन। um in logging a lorry, okay.
Sir, our answer is 150, 150 and 600.
150 and 600. 150 for which part and 600 for which part?
150 for A and B and 600 for C.
ठीक है, वुड बी गुड अगर आप यूनिट्स भी साथ इनके मेंशन कर दिया करें. 150 जूल्स एंड 600 वोट्स.
Watts.
600 वोट्स गलत है.
Okay.
It should be ठीक है. 150 जूल्स है. टाइम इज 1 मिनट. तो 150 जूल्स इज पर बॉक्स. अच्छा, टाइम को आपने 60 में कन्वर्ट नहीं किया होगा, उसमें सेकंड्स में कन्वर्ट नहीं किया होगा.
Yeah.
ठीक है जी. तो इसमें हम क्या कर देंगे, एनर्जी किस तरह हमारी आ रही है या वर्क डन हमारा किस तरह आ रहा है. फोर्स इनटू डिस्टेंस, W is equal to F times D, which is 100 into 1.5, so it comes out as 150 joules. And then power is equal to work done per unit time. So work done I've got 150, time I've got 1 minute, which is equal to no, in fact it's talking about 4 boxes. The 4 boxes के लिए it will become 4, and time will be 60 seconds. So 150 times 4 is 600 divided by 60. I get 10 watts.
Okay.
ठीक है जी, ये हो गया. The next question. Uh, यूनिट्स का ख्याल रखें. यू हैव मेड दिस मिस्टेक मैनी टाइम्स बिफोर एज वेल. आप वो यूनिट्स की कन्वर्जन जो देखा करें कि डिस्टेंस वी नीडेड टू बी इन मीटर्स, टाइम वी नीडेड टू बी इन सेकंड्स. What is its average power? What is
ये 12 seconds है.
हाँ जी.
Is the answer 500 watts?
Is Is the answer 500 watts? It is. It is. Untitled.
Sir, what is this find power needed to?
Do this.
Okay. Is the answer 3,500 pounds?
Is the answer? Is the answer 3500 watts?
Yeah.
जी correct. अच्छा. हम्म. ठीक है जी. अच्छा. Next what have we got? Hmm. There is an energy transfer. There is an energy transfer. अच्छा, you get questions in your exam. There are different forms of, for example, there are different phenomena given, and you are to tell that what form of energy is being converted into what form. ठीक है, तो थोड़ी बहुत हमने प्रैक्टिस की थी. हेयर ड्रायर में कौन सी एनर्जी कन्वर्जन हो रही होती है?
Electrical to heat energy.
ठीक है. अच्छा जी. KE and heat energy because it generates some wind और वो मूव कर रही होती है with some velocity. रेफ्रिजरेटर में
Um,
इट्स ऑल्सो इलेक्ट्रिकल एंड हीट एनर्जी. अच्छा, हमारे पास एक चीज वी नीड टू नो कि देर इज नो सच थिंग एज कोल्ड or coldness or whatever.
okay.
There is just heat and absence of heat. So when there is heat, we say that something is hot, or that the temperature we see it by the rise of temperature, but the absence of heat, the coldness or the cold that we have around us, it's simply the absence of heat. It's not that something else exists which creates that cold temperature or cold atmosphere. ठीक है? अच्छा, तो रेफ्रिजरेटर में भी इट्स इलेक्ट्रिकल एनर्जी टू हीट एनर्जी, एंड कुछ तो उसमें हीट एनर्जी द रेफ्रिजरेटर इट गिव्स ऑफ while doing refrigeration, and the other phenomena that it does is the cool wind that it throws within the refrigerator, it's actually sucking heat energy out of that air. अच्छा जी, ऑडियो सिस्टम हमने डिस्कस कर लिया था। ऑडियो सिस्टम में क्या होता है? इलेक्ट्रिकल टू साउंड एनर्जी, ठीक है। अच्छा, देयर इज अनदर क्वेश्चन दैट देयर इज ए गैस fired power station, gas fired power station. अच्छा, another small thing. Since so far you have been doing correct, questions correct, okay, and looks like you have got hang of this trick. But whenever you get a numerical question, the first thing that you always look for is कि what is requirement. Okay, what are you actually required to calculate out of this question? This is not only for physics, for even biochemistry, for any subject ever. If ever you get a question, the first thing that you try to decipher is कि असल में पूछ क्या रहा है, what do they want from me, के चाहते क्या मुझसे, किस किस्म का आउटपुट चाहते हैं, ठीक है? And the second thing that you look for is data given, कि क्या different forms of data points जो हैं वो मुझे दिए हुए हैं, ठीक है? अच्छा, the third thing that you try to do is you try to form a connection between these data points to the requirement, usually using a formula. Okay. One, two, or more formula, but there has to be a way that using these data points and doing some calculations, you arrive at the requirements. So this should be your thought process whenever you get a numerical question, or even for the subjective questions. अच्छा जी, अच्छा जी. Gas-fired power station is energy input 1000 megajoules, energy output is 300 megajoules. HG efficiency, you have to calculate efficiency in converting energy in gas to energy, electrical energy input.
Okay. Is the answer 30?
It is 30, but usually for efficiency we give answer in the form of percentage. वैसे भी आपने देखा था multiplied by 100% calculate हो रही है तो we'll say 30%. अच्छा, there is 30% efficiency. अच्छा, so what does it mean that how much is the loss of energy? Both in terms of 70%, that would be in terms of percentage, and in terms of actual loss, how much would it be in this case? Simply energy input minus energy output, that is 700 megajoules in this case.
Yes.
ठीक है. अच्छा, what form does it take? What becomes of this lost energy? I mean, where does it go?
As like sound energy, heat energy.
The large bulk of it in this case would be heat energy, and it would be warming the surroundings around that power plant. इसलिए हमारे पास कई जो बहुत energy intensive machinery run हो रही होती है, we usually have to install a cooling system around it as well, because a lot of energy is wasted as heat energy around it. ठीक है. सिस्टम्स हमारे कंप्यूटर्स जो हैं जो बहुत ज़्यादा हैवी प्रोग्रामिंग या हैवी बर्डन वाले सॉफ्टवेयर्स रन करते हैं या applications run करते हैं कंप्यूटर पे, they have to install separate. Gamers, I don't know if somebody around you is into gaming or not, तो उनके कई दफ़ा जो लैपटॉप्स होते हैं उनके नीचे there is this thing, उसको फैंस चल रहे होते हैं to keep their machine from getting heated up. अच्छा जी, ये हो गया, ये हो गया, ठीक है. The next thing that we have got is the two forms of energies which we encounter the most. एक हमारे पास kinetic energy है और एक हमारे पास potential energy है. Ke, I told you the other day that it's calculated using the formula half mv squared. ठीक है. So this tells me that the more the mass of an object, the more Ke it might have, and the higher the velocity of the object, the faster it is moving, the more kinetic energy it will have. Similarly, if I were to give you momentum of an object, can you calculate kinetic energy of that object using the momentum?
Yes.
How?
Because momentum is mass times velocity.
So momentum multiplied with velocity and divided by 2, or momentum multiplied with half of velocity gives me kinetic energy. अच्छा, इसी को अगर मैं ब्रेकअप कर लूँ, ये जो मेरी ओरिजिनल इक्वेशन थी, हाफ एम वी वी, एम वी इज मोमेंटम, so it becomes half p v, right?
Yeah.
So it could be that I get a question in which I'm given simply the momentum and the velocity of an object, and still I'll be able to find out its kinetic energy. Acha, this equation of kinetic energy, its derivation is not in your course at IGCSE level. A levels में या आपके कोर्स में आती है, तो अगर आप A level की फिजिक्स पढ़ेंगे तो वहाँ you will get to derive के how do we come about this. I mean, why do we say कि it's half mv squared, why not something else? अच्छा, तो वो आपके A levels के कंटेंट में कोर्स लेवल पे आ जाएगी. अच्छा, then we have got potential energy. Potential energy की derivation वैसे सिंपल है. Potential energy is the energy that an object gains by virtue of its height, right? Another way to define potential energy is work done against gravity. Work done against gravity. Work done के लिए we have got formula force into distance, and when we are doing work done against the gravity, the amount of force that we have to apply is equal to the weight of the object. And to do work against gravity, we have to lift up an object because gravity is pulling things down. So to go against gravity, we have to lift things up. So we have to give this thing some height, and W we know is equal to mg. So mgh is potential energy. Okay, so if somebody, I mean, the data could be given in the form of mass and height gained. The data could be given in the form of work done and height. ठीक है?
Okay.
अच्छा जी, no, not work done and height, weight and height. Sorry, my bad. Weight and height.
Okay.
अच्छा जी, अच्छा जी, ठीक है. We know that falling body is a body at its maximum height. For example, if I take a ball up to this height, the ball has got mass m, and from ground it is at a height h. So at this particular point, PE would be equal to mgh, and if I'm holding this object intact, or if I'm holding this object in its position at this point, its ke will be 0. ठीक है जी. So as I allow this object to fall down, and it say it reaches this point, now its height is no longer h. Let's say it lost a height of x, so its pe will become mg h minus x, which is its height now, and this object would have attained some velocity at this point, so its ke would be half mv squared. ठीक है जी. And just when this object hits the ground, it would have lost. Okay, so what happens over here, at this point it has just got pe, at this point it has got pe plus ke, and just when it hits the ground, it will have just kinetic energy. It would have lost all its potential energy, which would have converted into kinetic energy, and all it would have is uh, kinetic energy. So here pe will be equal to 0, since height is 0. Here, since velocity is 0, so I would say p is 0 since height is 0, and here ke would be maximum, because it would have its maximum velocity just when it hits the ground, and it would be half mv squared again. अच्छा जी, अच्छा जी. हम्म. अच्छा, इसी तरह से लॉ ऑफ कंजर्वेशन ऑफ एनर्जी जो है, दैट टेल्स मी, oh my god, what did, okay. Law of conservation of energy tells me that energy lost is equal to energy gained. So let's say if I'm losing mgh and I'm gaining half mv squared. So, acha, equating these two, we can find out a number of things. So, for example, we can find out, if we cancel things out or we simplify things, m cancels m. So, gh is equal to v squared by 2. 2gh is equal to v squared, and v is equal to root 2gh. ठीक है. अच्छा, using this, if we were to prove what's the value of g, so we could use g is equal to v squared by 2h. In short, we can rearrange this equation in a number of ways, and we can find, for example, if we are given a few values and just one is missing, so we can find out that missing value using equating these two equations. Achha, there was one question that I meant to ask when we were doing the last few questions of the last chapter. I forgot. If you were to design an experiment to calculate how much power do you have, how would you do that? I mean, could you do that?
How much power are we have?
Any person, for any person, not necessarily you. I mean, we human beings, we have energy, and for a particular amount of time, we are carrying out work, or we are using that energy. So that shows that we have power as well. Okay. So if I were to calculate power of any human being, how would I do that? I mean, could I design an experiment to do that?
Um, you could calculate how much work a person does.
How? I mean, design an experiment.
Like you could measure the person's like weight and then
The person.
multiply it by the
अच्छा,
distance that the
आपने
person.
मुझे क्या क्या बताया? प्लीज रिपीट. आपने मुझे कहा कि I need a person's
Yeah.
weight of a person. ठीक है. How would that help? How would I use this?
Then we multiply it by the distance of the person actually walks or
Distance walks. But wait, when he is dragging the distance, अच्छा, this could be one way कि आप ये देख लें कि ठीक है, this could be one of the ways कि अगर हमारी energy loss कोई नहीं हो रहा, let's say कि there is no energy loss to friction or air resistance, so what is every person, they have got their body weight and they have to drag their body weight as they run. ठीक है, they have to carry this body weight. So how much distance are they? What is the maximum distance they are able to cover? Carrying their own body weight. Okay, that would give me, but that would give me work done. This will give me work done, and then I'll divide this work done. So, for example, let's say I give them a time of 1 minute. Okay, how much they are able to run in 1 minute. So I'll divide that work done with time. Okay, we could design a number of experiments. So, for example, we could say that there are these 10 kg boxes, many of them, and there is this table 1 meter high. How many boxes in 1 minute is a person able to pick up from the floor and put on top of this table? Okay, so for each box, since it's 10 kgs, weight will be 100 newtons. Okay, that would be the force for each box. The height that they have, I mean, picking up this box from here and put it on top. So for each box, they are doing a work done of 100 joules, right? Force is 100 newtons, and so the number of boxes they're able to put on top of table divided by 60 again, because we need the time in seconds. That will give me the power of that person, average power.
okay.
ठीक है. अच्छा जी. uh, this give me a second. uh, hmm, hmm, hmm. अच्छा. uh, we could look at the example of a pendulum as well. So for example, if there is this pendulum over here, okay, if I move it to this extreme, okay, it gains this
Okay.
small height h from its mean position. अच्छा जी. Because of this, at this point when it's stationary and standing over here, PE would be 0 and KE is also 0 when it's stationary. But let's say I move it to this point. At this point, it would have gained some height, and its PE would be equal to mgh.
Yeah.
And then when I let go of this moment, this pendulum, let's say at this particular point, it will have some height that would be small, but there would be some height. So at this point, it will have PE plus KE. and when it comes back to its mean position, it would have gained a lot of velocity, and it will have just Ke and no Pe, and then it would then go on to the other side, and as it goes on to the other side, it would start gaining some Pe and start losing some Ke until it reaches this maximum height again, and there it would again have Pe and no Ke.
Okay.
And at this particular point, let's say it will have Pe plus Ke. अच्छा, similarly, in real life around us, अच्छा हम फिजिक्स में कई दफ़ा लॉज डिराइव करने के लिए we assume things which are not 100% true in real life. So, for example, to derive all the laws in physics, we say that um, there is no, assume there is no air resistance. Yeah, assume there is no friction. Okay. So, similarly, we say in a perfect system, we back in my days, all the textbooks they kept using this term in a perfect system. ठीक है जी, perfect system क्या होता है? Perfect system is the one in which there is no energy gain or energy lost. ठीक है, there is no energy escaping from the system or coming into the system. Such systems they are really difficult. I mean, in scientific labs, after a lot of effort, we are able to get close to such systems, but in real life, we are far from these perfect situations and perfect systems. हमारे पास एयर रेजिस्टेंस भी होती है, हमारे पास फ्रिक्शन भी होती है, हमारे पास एनर्जी लॉस भी होता है. अच्छा, तो then what's the use deriving these laws in perfect system, and in real life all these things they come into play: friction, air resistance, energy loss. ऐसा क्यों करते हैं हम कि why do we derive in laws in these laws in systems which are not necessarily replicated in everyday life?
Um, because it makes it easier.
Theoretically, yes. Theoretically, there could be a, so for example, case that it's easier to do so. But when we are doing science, we have to be objective rather than do what's easy.
The energy loss is very minor, so it doesn't matter.
ठीक है, एक ये second argument is that the energy losses that usually occur, they are most of the times very minor. अच्छा, the third and the most important reason could be, क्या आपके ध्यान में है कोई और reason? Could there be another reason?
I don't know.
ठीक है. All the laws in all the for example branches of science, they are derived initially without any consideration that if we only let this particular force come into play, or if we only let this one particular variable come into play, what would be the effect? Okay, to completely understand impact of one variable, we have to assume every other thing to be constant. We do that even in social sciences, even in economics we use the term ceteris paribus sometimes. ठीक है, आप economics पढ़ेंगी अगर आगे कभी तो आपको पढ़ेंगी कि assuming everything else is constant, if I just change this particular thing, what would happen? अगर आप ऐसा नहीं करेंगे तो you won't be able to understand the particular effect that relates to just this variable. ठीक है. So for example, if there were air resistance in this particular example that we just did of pendulum or any other thing, friction या हम वो चीजें मॉडल कर लें, तो we won't be able to understand the true effect of potential energy or kinetic energy. So to get the true effect solely of potential energy or kinetic energy or some other variable, we have to assume other things to be constant. And once we have derived the law, then we can always incorporate the changes, the minor changes, or the changes that are around us to fine tune it to real life situation. But to get the essence of any particular variable, we have to at times and most of the times assume other things to be constant. ठीक है जी. अच्छा, हमारे पास एक और छोटा सा केस है which is of elastic and inelastic collision. Elastic collision and inelastic collision. ठीक है जी. So do we know what is the difference between elastic and inelastic collision?
An elastic collision might be the one in which the objects colliding can be stretched or compressed, but in elastic they cannot be.
ठीक है, यहाँ पे we have got a slightly different definition of what elastic and inelastic is. Elastic collisions are the ones in which the velocity is conserved. So, for example,
Okay.
uh, if the two bodies they collide, and the velocities with which they collided are equal to the velocities with which they separated from each other after collision, they are the same. Then the collision is said to be elastic. And if there is some kinetic energy loss, then okay, if Ke is conserved, then such collisions are called elastic collisions. And if Ke is changed before and after the collision, K is changed for both. This applies before separately. Before and after the collision. This is total Ke of the system.
Okay.
ठीक है जी, ये हो गया elastic and inelastic collision. ठीक है, what else have we got? Let's move on to questions. Let's say there is a boulder of mass 4 kg.
Sir, what is the velocity?
हाँ जी, velocity is 20 meters per second. आप न्यूज़ फॉलो करती हैं? Have you heard of this Pakistan origin lady who has been named a regulator, federal regulator at USA in USA? There is this lady. She's just 32 years old. She is an associate professor of law at Columbia, and she has been named the chairperson of Federal Trade Commission in USA.
Oh, okay.
और डेली न्यूज़ फॉलो नहीं करती हैं यूजुअली?
नहीं तो देखते हैं हम, जैसे माँ बाबा देखते होते हैं।
न्यूज़पेपर की हैबिट है अभी दुनिया में या खत्म हो गई है बस? नहीं, ऐसा जेन्युइन क्वेश्चन। आई मीन मेरे घर से संडे को न्यूज़पेपर आता है।
शायद बाबा पढ़ते होंगे न्यूज़पेपर।
Sounds old fashioned now.
Is the answer for A part 800, please?
The answer for part A is 800 joules.
And for B, is it 0?
For B, it would be 800 joules again. Because see, the kinetic energy it has gained at the bottom of the cliff, that kinetic energy came from the potential energy lost. So potential energy lost is equal to kinetic energy gained. So that potential energy which it has lost over its fall is equal to the total gain Ke gained at bottom. So that potential energy will also be equal to 800 joules. So Pe of boulder on top of the cliff is equal to Ke of the boulder when it lands.
Okay. Is the height of the 20 meters?
Yes, the height would be 20 meters because we have got um, mgh is equal to 800. Mass is how much? 4. G is 10. H is unknown is 800. So you solve it and you get H is equal to 20. ठीक है जी. Let's keep it till here because my iPad has almost lost all the battery. तो कल इंशाल्लाह resume. कल is Thursday, right? ठीक है.
Yeah.
What we'll do is के कल we won't be doing past papers. There are a few things, small things which we need to discuss. तो ये कर लें तो फिर एक साथ ही आई बिलीव मंडे को स्टार्ट करेंगे. पास पेपर्स मंडे को कर लेंगे.
ठीक है.
ठीक है चलें. मे बी टुमारो इंशाल्लाह.
Yes.